Alright, this video was to demonstrate my final term project. So, yeah, let's start with modules. So over here, from line 6 to line 9, these three, so CMU Graphic is the only external modules I used, and I used Math and Random as internal modules. And on the left, you can see my structure. I have a main.py, a readme, and a calculation. The calculation now have nothing to do with this project, but I'm planning on adding the calculation feature to this project later, so it is kind of like a pre-built port for it. So I do have the import calculation side, and calculation .py is basically empty. If you're interested, you can go take a look. And okay, after that, my main structure is based on CMU graphics. I have the on-app start, on step. On step is basically just checking if you should fit the curve or not, and then I have redraw all. Also over there, I just put a helper function so it looks kind of neater. And over here I have the input table drawing, the section drawing, and then the curve, the selection section drawing, and the result drawing feature. And that draw sheet is just a helpful function for up here. And down there I have the on mouse click. That is to determine which function user have choose, and I have the on key press to do user input. And over here I have the graphing calculator class, basically just performing all the code fillings and generating all the app strings. And over here that function is to that serves for the graphing that I will demonstrate a little bit later. And then I have the regression model class. So the regression model class is a drawing class that we have the initialize so I have initialized all the methods in here, and over there I'm using these subclasses to rewrite these methods or functions. Yeah, it's not method. And yep. So for linear all the way to cubic, they're using simple linear regressions based on the Gaussian-Newton method. That's some stat stuff. And after that, I have the sine regression. That is a little bit more complex because linear regression does not work for it. So I actually have to do several layers of regressions over here. And yep, that's basically the whole structure of my code. And here comes the demonstration. So once you run main.py, this is the UI you'll get. On the left, there's a large column for users to input data. You can use the arrow keys to select which column, and the yellow one is highlighted. So you can put data like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And note this column only takes positive integers. And also, if you accidentally just put tons of them, you can use backspace to delete. It's basically like normal interface. And on the top right corner, there's a graph section, and you can see once I put the input, there's several blue dots being drawn representing it. And also I do have an auto scale, so the normal default is 1010. That is all the way to the top, but if I decided to go a little bit further, like 20, it will auto zoom for me as I put in the data. And down here is choose your function button. We have 4 functions: linear, quadratic, cubic, and sine. The default is chosen on linear, and you can just you can click on these dots to select between each functions. So I'm now demonstrating linear first because that data set is pretty linear. So after that, just click this giant button called fit, and then that will generate a linear function. And over there you can see a red line showing how this how the function being dependent to the best curve will visualize as on the graph. And down here you have the function fx equals 1x plus 0, and we have the r² value to put to see the actual calculated uncertainty. So more than that, we can start to choose quadratic functions. So we can do 1, 2, 3, 4, 5, 4, 3, 2, 1. Oh yeah, it's not linear. 7, 8, 9. Okay, so this one kind of looks quadratic, so I'll say it will be better to demonstrate. So again, we choose quadratic over here and hit the fit button, and just wait for it to fit because quadratic is taking a little bit more time to do so. And here we are, we have the quadratic function as well as the red line graphed for how it will visualize on it. Down here we still have the function, and also we have the r² value. And also we can use the same dataset for cubic because it's kind of similar. So the operation is similar, just choose cubic, make sure you input the data right, and click fit. Then just wait for it. Okay, so the output is nan-x. That means the cubic fit is kind of hard to find. Let's see, because I don't have a handy qubit function besides me, so I will just see if a smaller dataset will give it a function or qubit function. Okay, here we are. So over here we have the qubit fit that is actually generated from dots from linear function fx equals x 1x plus 0. Yeah. And okay, down here we also have the function and the r² value. And okay, so lastly it will be the sine fix. So I will change the dataset for sine fix because that will be easier to demonstrate what is going on. Okay, so for sine fix, I'm using a pretty similar to fx to the basic function of fx equals sine x. So I'm using 3 as a period. So we have 0, 3, 6, 9, 12, 15, 18, 21. So I'm now just saying 3 is approximately 1 pi. So the period kind of looks right. And also we have y, since that's a sine fix, we have 1, 2, 1, 0, 1, 2, 1, 0. So on the graph on the right, you can see on that in that blue dot, it's already looking quite like a sine fix. But then we chose sine, we make sure the data is right, and we just click fit. And here we are. And we have approximately 0.9 times sine, 0.5 times x plus 0.1 plus 0.9, and also we have the r². So yeah, that curve is quite accurate. And we can say, okay, what if you want a cosine fit, which I obviously don't have it on here, and the reason is pretty simple. Sine is just cosine with a pretty small offset, so we can input a cosine function, cosine data set over here. 2 1 0 1 2 1 0 1 2. That's a little bit of action. Okay, so over here we have on the graph you can see that is a cosine function, so we can still choose the sine and fit, and we have a kind of decent fit. Okay, so we have the R squared is 0.74. If you are not satisfied with that, you can just hit fit again, and if you're still not, hit fit again, and just find which one have the best. So for example, just keep pressing fit and see which function kind of looks good. Okay, so now the R squared value have increased to 0.78. Well, that's good enough for me, so I will just stop here, and yeah, also just save time for the demonstration. And yep, that will be the end of the demonstration.